Welcome to the Rain Alliance webinar, Increase Rain Efficiency with the new Gen2v3 features. Claude, I will hand it over to you now to introduce the speakers.
Thank you, Elizabeth. So welcome, everyone. Welcome to this Rain webinar about the Gen2v3 error interface protocol. So let me go to the next slide. So my name is Claude, working for GS1 Global Office, and here is the proposed agenda for today. So first I will start with a very high-level overview of the reasons why we decided something like 3 years ago to review the GS1 Gen2 error interface protocol. But before describing the new features, I will say a few words, and we'll just spend 5 minutes about the new GS1 EPC schemes. This is because in the example that we will discuss during this webinar, I will make use of a special EPC scheme, which is the DS-GTN+. Then I will try to explain how Gen2v3 can help managing a mixed population of tags and really focus on tags of interest. And I'm here really proud to be part of this webinar with Tom Frederick and René Martinez and Jim Springer. They all have been very instrumental in the definition and development of this new Gen2v3 error interface protocol. So Tom Frederick will explain what we call what is the fringe tag issue and show how we can be mitigated with the Gen2v3 feature. Then Jim Springer will take the mic to explain how Gen2v3 can make the capture of additional data much more seamless and efficient. And finally, René will say a few words about the Gen2x impinge initiative and how it is strongly related with Gen2v3. And of course, at the end of this webinar, we will have time for questions. In between, you can ask your question using the chat button. So let's start, and I'm sure that everyone attending this webinar today agree to say that Rain RFID is already a very efficient technology. But nevertheless, 3 years ago, the GS1 community has decided to update the Gen2 error interface protocol, and let's see why we took such a decision. So the first version of Gen2 error interface protocol has been designed something like more than 20 years ago, back in 2004, at a time where I would say having more than 100 tags in front of a reader was just a dream. But of course, it has been revised, and we made a Gen2v2 available something like 10 years ago, mainly to address issues like tag authentication, privacy protection, and also file management. But when you look at the basic commands for tag selection, for inventory, and also to access additional information stored in the RAIN tag, these commands have not been modified. So you are currently working with something, with a protocol that has been defined 20 years ago. So we decided to start the revision of the error interface protocol to resolve the new challenges that the RAIN users are facing today. So here is a summary of the 4 main reasons why Gen2v2 has been updated. The first one is to solve what we call the tag clutter issue, or stray tags. You know that more and more people are leveraging RAIN RFID, and that's a good news, definitely. But this means that there are more and more tags in front of readers. And in order to focus on the tag of interest, or the tags that really belong to your application, you need to be able to efficiently filter out all these clutter or stray tags. And this will allow readers to stop wasting time, if I may say, trying to capture or capturing unwanted EPCs or UII, and this de facto will increase the inventory speed. Another reason is about improving the tag selection process. This is related to the first reason, but today when you look at the way you can do tag selection, this is based on the perfect matching between a mask value and the data that is encoded into a tag. So there is no way currently with Gen2v2 to compare 2 different values and use logical operators like greater than or lower than. And to select the tag based on this result of this comparison. So this could be useful when, for example, you try to select a population of tags based on a value of an expiry date. So I will provide an example of that later during this webinar. Another reason is to improve the inventory reliability. We all know that tags or chips sensitivity is decreasing year after year, and this means that a tag can be read very far away from the reader. So today, this is something like 15 to 20 meters. But these distant tags will receive power from the reader that will probably just be enough to wake up them. They will probably not have enough energy or power to complete the entire inventory round. This means they will not be able to properly backscatter the entire ARM16 nor the EPC or UII after the ACK command. And this will create some kind of somewhat interferences. So we need now a solution with Gen2v3 to prevent this tag to participate to the inventory round. And the last reason is based on the fact that license plate tags cannot resolve all the business needs. What we mean by a license plate tag is tag that just carry a unique identifier, EPC, UII, that is usually used to access more information about the product that is stored in the cloud. So people want more and more to encode additional data in the tag, and this can be achieved by using the new EPC schemes that are described in the GS1 tag data standard, and I will say a few words about that in a few minutes. But this can also be achieved by using the dedicated user memory bank of a tag. But unfortunately, when you look the way it works, reading such memory bank is a kind of a guessing game. If you don't know exactly what has been encoded, so we need a new command with Gen2v3 to instruct the tag to backscatter what has been encoded. Nothing more, but of course, nothing less. So before diving deeper into some of the new Gen2v3 features, I'd like to spend a few minutes, as I said, to also speak about the GS1 EPC schemes. So you know RFID is made of RF, radio frequency, and ID, identification. So you can improve the air interface protocol as much as you can if the tags are not properly encoded or if they carry not relevant data, the overall benefit will be very low. So at GS1, at the same time we started the revision of the air interface protocol, we also started the revision of the tag data standard. So let's see what we made possible with the major TDS 2.x releases. An EPC or electronic product code is always based on the GS1 identification key, and by definition, it has to be serialized. So on the left, you can see all the quite old EPC scheme that has been defined a long time ago. The most widely used is certainly the SGT96. So it's a compound identification key made of a GTIN, a global trade item number that is usually encoded in EAN or UPC barcode, together with a serial number. And the -96 means that the EPC binary string is made of 96 bits that have to be encoded in the RAIN tag in the EPC memory bank. At the time we created all these schemes, we worked very hard to make the binary string as short as possible to make the inventory of all the tags at high speed. So of course, the issue is that when you want the tag to carry additional information, like for example, a batch number or production date, a country of origin, whatever, this additional data must be encoded in the user memory bank if the tag has one. And of course, if the tag doesn't have a user memory bank, this additional data must be stored somewhere in the cloud. In both cases, this means that the additional data cannot be captured during the inventory operation. And based on multiple requests from different sectors using RAIN, we decided to create 12 new EPC schemes. As you can see now on the right, these schemes are based on the same serialized GS1 identification keys, a GTIN, an SSCC, a GII, etc. So nothing really new under the sun, but we have the plus after the name of the key. after the name of the EPC. This means that you can now append additional data after the EPC itself. And since this additional data will be encoded in the EPC memory bank, it will be automatically captured during the inventory operation. So this is the first great improvement. The second improvement is that you will be able to more easily filter tags based on the value of that additional data. And I will show you how later during this webinar. So let's take the example of the sGTIN plus. There is a single bit after the EPC header to say, yeah, I will have additional data after the serialized GTIN. And this data will be appended and encoded, in the EPC memory bank. The GTIN value is encoded in a way that you don't need to know the length of the GS1 company prefix that is used to create the GTIN. All the digits of the GTIN are converted one by one, so that when you look at the hexadecimal representation of the EPC, you can see the GTIN value, and it's easier for you to filter tag based on the value of this GTIN. The serial number is of variable length, so this is also interesting because you will only encode what you need. The shorter the serial number, the shorter the binary string. And finally, since the toggle bit of the EPC is set to 1, this means that there are additional information. In that case, this is an AI 17, which in GS1 means this is an expiry date. And after the AI value, you will have the date itself, so you will be able to filter tag based on the value of the date. When you look at this other slide, you might have noticed previously that among all the new EPC schemes, there is a special one, I would say, that is named dsGTIN plus. Of course, once again, the plus means that you can append additional information to this EPC like all the other one. But in addition to the GTIN and the serial number, a date is automatically encoded. This can be a production date, an expiry date, or any of the dates that GS1 is proposing as an AI. And of course, this makes the binary string to be encoded in the rain tag a little bit longer. And to be clear, it requires 20 additional bits to encode the date. And in this example, the binary string is 136-bit long. So you need to make sure that your tag has enough memory capacity for such a long string. But the beauty of dsGTIN plus is that the date indicator and the date itself are always encoded at the same memory location of the EPC memory bank. So it becomes very easy to select tags based on the value of this encoded date. And if you want to know more about these new EPC schemes and TDS 2.x, please contact my colleague Craig Alan Repek. His contact details are provided at the end of this presentation. Now, look, let's come back to the main topic of this webinar, the new Gen2v3 error interface protocol, and let's see how we can solve the tag clutter issue. Usually, when you do inventory, you capture all the tags that are energized in front of a reader, and once the EPCs or URI have been captured, you try to find those that are of interest and really belong to your application. Of course, in order to avoid wasting time capturing unwanted tags, you can first choose which tag you want to inventory with the Gen2v3 select command. But select is a broadcast command, so that there is no way for the reader to know if it has been well received and interpreted by the tags. And after the select or multiple select commands, then you start the inventory process using the query command. And of course, you will inventory only tags that are still energized and that have been previously selected. But what happens between the select and query? Tags are moving in front of the readers. You can have selected tags that will exit the read zone before you start the inventory with the query command. And all the tags will enter this read zone. Furthermore, if you have complex tag selection criteria, the reader needs to send more than one select command, and this will increase the risk of missing tags of interest. This is, to my view, one of the reasons why the select command is not widely used. So what is the Gen2v3 solution for that? So we created two new commands named query X and query Y. So apologies for the name. We have not been very inventive, but this is really to make sure that people understand that query X or Y are related to the inventory operation. These commands can be seen as a mix of Gen2v3 select and query commands. But we don't have two separate processes, tag selection and inventory. This is now a single process. This, by definition, will remove the issue of moving tags between select and query. The first part of the new command is a little bit like the select command, the Gen2v3 select command, but we added what we call predefined filtering criteria to make the life of end users easier. For example, you can easily select tags that are GS1 encoded, that carry an EPC, or on the other way, only tags that carry an ISO numbering system, and get rid of all others. You can also focus on tags that carry, for example, a specific EPC scheme, like an SGT96. In that case, even tags that are encoded with, let's say, another SGT198 or an SSCC or DSGT Plus won't be inventoried because you will be able to focus on very specific EPCs. You can also inventory only tags that support a specific feature like a sensor, alarm, or tags that are battery assisted or that support the untraceable command. Gen2v3 propose other predefined filtering criteria, but it would be too long here to describe all these features during this webinar. So in addition to this predefined selection criteria, you can add another criteria within the same query X command in order to create more complex filtering criteria. And if it's not enough, you can add other additional selection criteria within the subsequent query Y command. So, okay, for the second part of the command of the query X, it's a little bit like a query, a Gen2v3 query, and it provides information about the way tags and reader will communicate. So it defines the backscatter link frequencies, BLF, the data rate, the modulation to be used, nothing new under the sun, but we leverage the revision of the standard to reduce the frequency tolerance so that it will be easier for a reader to detect the tag responses. We also added the possibility for the reader to check the consistency of the backscatter RN16, and this is mainly to improve the reliability of the communication. And we also made possible for the tag to use predefined values for the backscatter link frequency. And last but not least, I think, we can now instruct the tag to backscatter the TID instead of the EPC or URI during the inventory. So to summarize, the new inventory commands, query X and query Y, will definitely, I hope, help in focusing on tags of interest while making the inventory more reliable. Now let's say a few words about another very important new feature you can find in the query X and query Y command of the air interface protocol that includes the use of logical operators. So let's see how it works. So suppose you have in front of you, in front of the reader, a mixed population of tags with different encodings. Some tags carry GS1 data, others not. Within the GS1 family, some carry the commonly used SGT96, no date in such an EPC, but others carry a DSGT Plus. But if you look carefully to the different DSGT Plus tags, you will see that some of these tags carry a production date and others carry an expiry date. And these tags that are the tags of interest for me. So from a reader point of view, the reader will ask a simple question. I want only to inventory the tags that carry a DSGT Plus, for which the date is an expiry date, and for which the date is lower than, in this example, the 15th of September 2024. So let's see how it works. The first thing to do using the query X command is to say, using the predefined criteria, is to say, I want to only inventory GS1 encoded tags. All the other one, none that does not carry an EPC, will not be inventoried. Then you say within the same query X command, you will say, oh, by the way, I want the GS1 tag to carry a DSGTIN plus EPC scheme. So you will remove from the inventory all the other GS1 tags, like for example, the SGTIN96. This one will not be inventoried. Then you will say, oh, by the way, I want also that the DSGTIN plus carry an expiry date, not a production date, not a frozen by date, not the best before date, only expiry date. So everything is made within the same query X command. And finally, cherry on the cake, you will say, oh, I want the expiry date to be lower than the 15th of September 2024. And in that case, you will see that in this example, only one tag will be inventoried. So you will easily detect if there are any expired products, if you are using, obviously, DSGTIN Plus and Gen2v3. You can imagine other selection criteria based on the value of a serial number. You will probably want to only inventory a given range of serial number or given range of GTIN, things like that. So everything is now possible with the new query X and query Y command. So that's it for me. I will now hand over to Tom Fredericks to speak about the way Gen2v3 can resolve the issue of the fringe tag issue.
All right. Thanks, Claude, for the well-prepared slides here. If you can go to the next one, please. All right, so this is an overview of the problem, starting from the left, a reader connected to a tag. It's illuminating a read zone that's have some tags of interest in it that are powered up and ready. And then further to the right is a fringe field where it's not reliable reading zone. Tags are designed to optimize sensitivity, and so they may often make their best effort at participating in inventory rounds. So these tags are powered up, but they're, as we'll see on the next slide, they're not able to complete the inventory. And then further to the right are tags that go back up one slide, Claude. So one thing on this slide is the density of tags that I'll comment on. That if there's a uniform density of tags, there can be a lot of tags on the fringe, not just two. Yeah, I think this new spec allows for up to 2 dB of field adjustment, which accounts for about 25% of the read zone. So whatever the good read zone is, there's an additional 25%. And if you have some large uniform population of tags, that ends up being a fair number of tags that can be unsuccessfully participating in the inventory process. So next slide, please. This is a different illustration of the problem. These are the signals captured using a field probe, so you can see the reader command modulation, and you see the tags backscatter. So again, from the left, the tags that are well energized are able to respond and give their EPC and then be quieted and through the normal defined process in the spec. But as you proceed into the fringe, you get tags that are pretty well energized, but they drop out when they try to send their EPC. Or further out, you get ones that drop out when they try to send an RN16. Now these tags essentially create a collision situation, or the reader's got to interpret what's happening, because for best throughput, the reader has to estimate the tag population and appropriately size the frame for the protocol. And if the frames are way too big or way too small, then throughput goes to zero. So anyways, the fringe tags on the left are more troublesome because they don't drop out of the round until they actually get ACT and try to send their EPC, whereas the ones on the right drop out. They interfere with at most one round, and then further there's no response. So next slide, please. So the solution is this field adjust idea. On the bottom there, it shows, field strength versus time. It's the reader starts out at some point at full strength, whatever that is. And you see up above the little infographic shows how the field is, where the field is for that full strength transmission. And then prior to sending out the commands that start the inventory round, the reader modulates its field strength down by, again, up to 2 dB, I believe. And it dwells there for a moment, maybe 500 microseconds before sending out the command. Now, at this point, the field is contracted, as you see above, to where these fringe tags are going to drop out. They don't have sufficient power to respond to the query X command. And immediately following the query X command, the field is ramped back up again to full power, which gives everybody in the interrogation zone and the read zone sufficient power to accurately complete the process. So it's a very nice solution. I don't know who thought of it. It wasn't my idea, but it works very well. So that's it for my part. Thank you.
Thank you, Tom. Now I hand over to Jim to speak about other Gen2v3 additional feature, mainly about the access of additional information as encoded in the user memory bank.
Thank you, Claude. If you can go on the next slide. So Claude had mentioned in the beginning that there are certainly applications where more and more data is required to be on the tag, and traditionally it's been put into user memory. And as he mentioned, it was always a guessing game in terms of how much memory do I read and can I do it conveniently. And what's been done now in Gen2v3 is to address some of these issues. And the first item that was introduced is the read user memory indicator bit, or we just call it the RUM indicator bit, and it's in the PC word, and it replaces the Gen2v2 user memory indicator bit. Functionally, it's the same as the UMI whenever you use the Gen2v2 commands select challenge or query for backwards compatibility. However, there is new functionality when you are using the Gen2v3 query X, query Y commands, and the RUM value is based on another new Gen2v3 concept, which is the user word count value for the user memory bank. And it functions very much in a similar manner to the L value for the EPC memory bank. And that is, it basically says how many words will be backscattered from user memory. And RUM equals 1 is actually a little more useful in the Gen2v3 than the UMI, in that the bit tells the interrogator that user memory contains application data and that data should be read. The UMI bit in Gen2v2 only tells you there is user memory. It doesn't tell you if it's actually being used. It doesn't tell you if there's any data in user memory. But the RUM bit will actually sort of self-direct readers that you need to go read user memory. So if you can go to the next slide, please. So this is a simple example, and certainly chips that have user memory, you'll find chips that have 2 words of user memory, 8 words, 16, up to a few kilobits of user memory. But for this example here, we're just assuming here's a tag that has 6 words of user memory. And we're going to demonstrate how this new read var, it's a read variable length command in Gen2v3 works compared to the Gen2v2 read command. So in this example here, we have the 6 words of user memory. We have 3 words of application data that are the first 3 words, 0, 1, and 2. We have 3 unused words of user memory, which is the words 3, 4, 5. And if we were to issue a read command where we set our word pointer to 2 and we ask for 5 words of memory, What would happen with the read command is that you would just get an error code. You would get no data, no other information other than here's an error code, you're trying to read non-existent memory. With the read var command, it will return from the word pointer up to the total number of words in the user memory bank, even though there's going to be some data that's not of use to the application. There's also a parameter in the read var command return that says how many additional words are available to be read, which you did not read. And finally, it will return only the words that could be read. So it's returning words 2, 3, 4, 5. So this is to try and make it eliminate part of the guessing game in terms of if I tried to issue a read command and I got an error code, what did I do wrong? Let me try again. So this helps to eliminate that problem. If you go to the next slide, Claude. So oftentimes to solve some of that problem in Gen2v2, we simply do a read command on user memory when we set word pointer to 0 and word count to 0, and we say read everything. So in this example here, where we have 6 words of memory, the read command would return words 0, 1, 2, 3, 4, 5. However, you're reading a bunch of words that have nothing to do with the application. This example with 6 words perhaps is not so bad, but if you have large memory tags that have 8, 16, 32, or 64 words of user memory, you can read a lot and spend a lot of airtime reading something that you're collecting data that you have no need for. So with the read var command, what it does is it makes use of this value called the user word count that we discussed, where it programs into the tag that says, when I see a read var with word pointer 0 and word count 0, I know to backscatter all the words starting from word 0 up to the value of the user word count. And that's all the data that would be of interest to the application. So you end up in this example here where I only have 1 word of data that's been programmed for the application. If my user word count then is set to 1, then read var would return 1 word of application data, but I would also return more words that there's 5 available in case you wanted to read them. And they may have secondary application data. And finally, it tells you more words. Well, you read all the words that are, or all the words that are possible. It tells you there's no more words than the additional more words value. So this is how it works on user memory. It also has some similar benefits for reading TID memory. But the end result was to try and eliminate the guessing game when you're reading data from the user memory bank and to some extent from the TID memory bank. Next slide, please. Lastly, there are a few other features. We're not going to go into details here, but Gen2v3 has now aligned itself with the ISO version of the protocol spec. So it will support the passive sensor tags, whether they be the snapshot sensor class of sensors or tripwire sensors, which are commonly tamper detection or threshold sensors. There's a new power up and settling time that's been added into the protocol. Renee's actually going to talk a little bit about this. There's also an increase for the time before the first command, which is actually quite significant addition to the protocol. For those in the chip industry, as Claude said, the spec is 20 years old. In 20 years, we've made a lot of progress in terms of features and performance in chips, but it does take time. And the time is often spent, whether you look at chips that go out and do an adaptive impedance matching with the antenna to maximize power transfer, whether the chips are doing built-in self-test on memory, looking for memory issues or bit flips, whether chips are doing sensor measurements. So there's more and more stuff that is going on inside chips, and frankly, more time is needed to do so. And lastly, for some optimizations for crypto chips to simplify the logic, minimize the amount of silicon needed. There's some effects on the crypto commands for the response buffer and the storing of responses in memory. So if you're a crypto user, you'll recognize these terms. If you're not, you won't. But if you have any questions, you can always reach out to people on the presentation today. We're all kind of pretty well versed in the protocol. We'll be glad to talk with you. And with that, Claude, I turn it back to you.
Thank you, Jim. And now I would like to give the floor to René Martinez from Impinj and to speak a little bit about the new Gen2X Impinj initiative, just to make clear what's different with Gen2v3 and what are the things that are equivalent to what we can find in Gen2v3. So, René, you can unmute yourself. We'll go through your slides.
Thanks, Claude. Impinj started working on Gen2X years ago to address embedded use cases in small tags. Later on, when the Gen2v3 charter emerged, Impinj realized that some of the Gen2X concepts we had been working on could also apply to Gen2v3. In December of 2024, Impinj released Gen2X to the RAIN industry, and it's now available in tag and reader products. Claude graciously offered Impinj a few minutes to talk about Gen2X in this Gen2v3 webinar. But for further questions about Gen2X, I just would point you down to the bottom of this slide to refer to the link. After all, this is a Gen2v3 webinar. At its core, Gen2X enhances the radio and logical layers of Gen2 to improve the tag readability, speed of inventorying tags, boost read accuracy and reduce stray reads, declutter tags, and also offers a protection aspects such as inhibiting counterfeit items, and also protects the tag data and enhances consumer privacy, which is germane to the embedded use cases. Some of these Gen2X capabilities overlap with Gen2v3, while others are features or enhancements to Gen2. And in the next two slides, I'll show you two examples of this. If you can go into the next slide, Claude. As Jim alluded to, there's a new power-up envelope in Gen2v3, and focus, if you will, on the left side of this slide, the diagram there, which is the Gen2v3 power-up transmitted by the reader, and it shows field strength. The blue line there shows field strength versus time. Now, on this diagram on the left, the content in blue and black ink is from the Gen2v3. And I like to say that this new power-up is longer and stronger. It's longer in time and optionally higher in power than the 1.0 nominal A field strength there. Gen2X has this additional restriction in red ink there that makes sure that in the initial power-up from the reader to the tag is significantly larger. So it's sort of a self-imposed restriction there to make sure that the tag gets hit with a lot of power in the beginning to make sure it initializes and goes through all those details that Jim mentioned before. With this initial power boost, what we're calling a Gen2X power boost, it sometimes improves the tag sensitivity by 2 dB, which corresponds to a 20% increase in range. You could exchange range for other factors. For example, it improves the resilience of the tag to environmental factors such as material loading, i.e. putting the tag on different dielectrics, and enables smaller antennas, which thus enables smaller tags. And lastly, the power boost expands upon at least our products and Impinj's M800 tag sensitivity, which is already 1.5 dB higher than the M700. So so this is again an example of working within the Gen2v3 confines to do some optional behavior that really helps with tag range. So if you could go to the next slide, Jim, is my second example here. Gen2X also includes this capability called protect mode that directly addresses embedded use cases for tags. With the protected mode enabled, tags are non-responsive to readers unless the tag receives a secure pin code, 32-bit pin code. It might be easier to see how this works if you focus on the diagram on the left. It's on right now, so let's wait for a moment and it'll turn off. The protected mode will turn off in just a moment. There, it's off. When it's off, it acts as a normal tag, and tag data responds. When it's turned on, there's no response to the tag. But then, if the reader transmits this password or PIN, the tag will reply. So this is another example working within the confines of Gen2 to enable consumer privacy and other things. That are helpful for embedded use cases. As you can see in the bottom point there, that it uses standard Gen2 select and block right and write commands to enable and disable these responses. So those are two examples. Again, as I stated earlier, I want please refer to the website for further information about Gen2X. Thank you, Claude. That's it.
Thank you, Rene. Thank you, everyone, for your time today. It's time to make a kind of summary to have the opportunity to answer any question you might have. With regards to Gen2v3, I think we can say we can now reach the top of the mountain. Where are we today? As you know, the new EPC schemes that are defined in TDS 2.x can already be implemented in existing Gen2v2 tags. You don't need to wait to implement the new air interface protocol to benefit from these EPC schemes. This is already, I would say, a giant leap, since it allows you to encode and efficiently capture GS1 data in addition to the EPC itself. But if you want more information, as I said, about GS1 TDS, please reach out to my colleague, Craig and Repek. With Gen2v3 interface now, you will be able to increase the inventory efficiency with tag selection and EPC or UII capture in one single command. And this command provides predefined selection criteria as well as logical operators. As explained by Tom, the field adjustment will drastically reduce the issue with the fringe tags. And regarding the access to other information than EPC UII, the TID can now be captured during the inventory. And Jim also explained that the capture of any other relevant information, either encoded in the TID or in the user memory bank, is much more easier and efficient thanks to the definition of the run bit and the use of the new readvar command. And Jim also explained that GS1 Gen2 air interface now supports passive tags. So I would say with all these improvements, I'm sure that once you will have implemented this new standard Gen2v3, you will probably adopt it and will never want to come back to the previous version. So I think now it's time to give the floor to the audience and to ask any question, answer any question. And of course, this slide deck will be shared with the RAIN community so that you can contact all the speakers as well as Craig and Repek, as I mentioned. And there is also just a final information. There is a new RAIN document that has been recently published that make a summary of all these new Gen2v3 features a little bit more in detail than that we have just explained today. Oh, sorry, my camera was off, so I can see. So I don't know, Elizabeth, how you would like to manage the Q&A session now?
Absolutely. So the first question we received is, what are the memory size to allow this new schemes? And that came during your presentation, Claude, your first presentation.
Okay, yeah, this is not related to Gen2v3, but to the new EPC scheme. So it depends, because the more information or more additional information you will encode or you will append to the EPC, the longer the binary string. So it could be something that is around 96 bit if you have a short serial number, but it can go up to a few hundreds of bits. So it's really a question of balance between the information you want to encode in the EPC memory bank of the tag and the size of this memory bank. But we have a tool within GS1 that you can leverage to assess the length of the EPC's binary string, depending on the number of AIs and the length of the serial number that you will encode, that you want to encode. It will provide you the number of bits of number of words that you will have to encode.
And then we have another question. Can you provide an example of Gen2v3 being used with sensor tags? Any key advantages over the previous generation in this sense?
I would like to give the questions, the floor to Jim, because
Sure.
it's about.
I'd be glad to do that. Yes, in general, I mean, there are many, well, I shouldn't say many, but there's quite a number of products out there that are sensor tags in different forms. There's also, in ISO, has always controlled for this protocol, what are the definitions for sensor tags? And there's several classes defined by ISOs, and they all have some common features. Some of the products on the market today that are sensor tags are fine products, but they don't necessarily use the feature set defined by ISO. And now what GS1 has done is aligned the protocol on the GS1 side of the house with the ISO side of the house. And I can say that the way the protocol works with Gen2v3 is with the Gen2v3 query X, query Y commands, you can now directly select on sensor tags. You can also directly select sensor tags that have alarm conditions. So it's done automatically during inventory. You can say, I only want to inventory tags that have sensors. I only want to inventory sensor tags that have alarms. So that's going to be the main advantages there. If you are really interested in details, just reach out to me at the email and I'll discuss it more with you.
Jim, I'd like to add also the new power up of Gen2v3 allows more time to do sensor processing. So that's, I guess, an advantage, right?
That's correct. On the snapshot sensor tags in general, at least on the products EM makes, the sensor measurements are normally done during power up, so that during inventory, the sensor measurements are returned automatically when an inventory occurs, and all the sensor information is exchanged via XPC words, which is part of the ACK reply.
Great, thanks. Another one we have is, will users / retailers who currently specify SGTIN 90.96 be able to accept and use SGTIN tags with their current readers? The use case is that some retailers will be ready to use SGTIN ahead of others.
Yeah, sure, of course. I think as I wasn't probably not clear enough when I made a presentation of the new SGTIN plus scheme. This is something new, but fully compatible with the Gen2v3 error interface protocol. It's just a question of a new way to encode a JITIN in its serial number. I would say to let the opportunity for those who are migrating from the barcode EN or UPC barcode to migrate to the RAIN technology. Because when you encode an SGT96, what you need to know is the length of the GCP, GS1 company prefix, because this is the way SGT is built. Now with the SGTIN Plus, it's just encoding all the 14 digit of the GTIN with a 4-bit per digit. So it means that it's much more easier for someone to migrate from barcode to RFID. The only difference I would say is about the length. With SGT96, it's a fixed length, 96-bit long. So whatever the serial number, it will always be 96-bit long. With an SGTIN Plus, depending on the length, and if the serial number is made of digit or also include alphanumeric characters, the length, the overall length of the EPC scheme will vary. So you need to make sure that at the end, you will have enough memory capacity to support the long SGTIN Plus encodings. And as I said, if you append to the SGTIN additional information, of course, this will make the binary string a little bit longer. So yeah, but currently with the existing readers and tags that are on the market, you can already leverage all the new EPC schemes.
Thank you. Just another comment saying thanks for all the great information. Could you explain why the fringe zone problem is a tag problem during an inventory and not a read point design problem where the user would have to place the reader/antenna everywhere? It would have to be for ensuring his good inventory.
Yeah. I can go back to this slide to explain the issue. Or Tom, would you like to take the question?
Yeah, I can take the question, Claude. It's you know, there's a model that was sent around for this. It's available. It's a throughput issue. You know, if you've got a lot of tags in the read zone and you see 25% reduction in throughput, this could be the drag on it. It's the tags come up and they respond. It looks like there are more tags in the read zone than there are able to actually complete the inventory cycle. So the frame gets bumped up. You know, it's once a tag is open for access, then it's no longer an issue. This is really just the case where you've got usually a lot of tags is where it's a problem, because if there are a few tags, it's not going to really drag the throughput very much for inventory mode. But you know, warehouses, retail environments, this could be an issue, and it's not hard to find problems where throughput is important. Does that answer the question, Claude?
The question was asked by Philippe Lallemand, so I hope it answers. Or otherwise, we can spend more time after this webinar to dive deeper into the fringe tag issue and see how it is and why it is an issue with high population of tags.
Okay, yeah, Philip, you can email me if you want, Claude.
Yeah, good.
All right, we just have, when can we expect Gen2v3 tags and readers to start appearing on the market?
Good question, and I will let Jim answer the question, and other chip manufacturers also on the call.
Oh, thanks, Claude. For those who attended the RAIN event in Italy, there was a presentation made, joint presentation from SBB and EM and from Microsenses, as I recall, discussing the EM Gen2v3 product that is being used by the rail operators in Europe. So EM is shipping wafers to the suppliers for those tags now. There's also That version is meant for industrial applications. There's also a version that's for high crypto security, and those are dual frequency products. There's a UHF only product that is also meant for high security and high memory. So wafers are being shipped, and there are some inlay manufacturers that are starting to make products. Now, EM tends to make value-added chips, so they're not commodity chips. They're going to have either sensors or crypto or dual frequency or a lot of memory.
Thanks, Jim. Just another follow-up question. It seems the solution for fringe tags in Gen2v3 is similar to power boost of Gen2x from Impinj. Is that correct?
Renee, can you take the question? Can you answer?
Yeah,
the
yeah.
question? I can, but
Yeah, unfortunately, they're different. They're different. You could think of a classroom, and in the classroom, there you have students, and some students have to be woken up and just jolted, and then they'll be like, okay, my name is Renee Martinez. Then there's other students that you try to wake up, and they do wake up partially, and they say, I'm Renee, and they forget to say their last name. So basically, they're two separate problems, and I apologize for using that student in the classroom analogy, but basically, if you hit the tags with a lot of power in the beginning, they wake up, but it doesn't guarantee that they'll preserve that that awakeness, if you will, preserve their awakeness so that they'll reply later when their last name is asked for. So they're two separate things there. I don't know, Tom, I don't know if you want to say anything else there too. Okay.
no, I don't know.
That's it.
Okay, no, that's good. But I think, yeah, more or less, it's also about modulating the field strength. For Gen2X, it is at the beginning when you boost and you provide the power, you wake up all the tags. With the fringe tags, it's more, we are modulating the field during the inventory, and just to make sure that the tags that receive the query X will be able, after this query X, to have enough power to backscatter RN16 and EPC properly. But yeah, the two solutions are based on somewhat modulation of the field strength.
Renee, correct me if I'm wrong. The boost is also in V3, right?
Yeah, it's an option. It's an
Yeah.
option.
Right. Okay. Thanks.
We got one last question. Would we be able to use existing readers via firmware update for Gen2v3 tags, or do we need to deploy new infrastructure to be able to benefit from the new protocol?
I think, Tom, you can easily answer this question.
Yeah, that's a firmware update.
And tags, just to be really clear, tags are backward compatible in that if you're using the query command right now with your older, with your previous version Gen2 tag readers, if you're using Gen2 readers, let's say V2 readers, they're using the query command, and they will work with new Gen2v3 tags, because new Gen2v3 tags also have the query command and are backward compatible from that regard.
That's a good point, Renee. Yeah, we forgot to say that all the existing Gen2v2 commands are still available in Gen2v3. So Gen2v3 just add additional commands to the existing air interface protocol.
Wonderful. Well, that's all the questions. Like the presenter said, if you have any additional questions, feel free to shoot them an email. Also, the recording will be made available on the RAIN Alliance website within 24 hours. So you'll be able to have that as well. But thank you all for a wonderful presentation. And Everyone have a great rest of your day.
Thank you,
Thank you.
everyone. Thank you for your time.
Bye to all.
Bye-bye.